Mars is barren and dry, like a vast desert with countless craters dotting its surface. At first glance, it seems incapable of supporting any form of life. However, in recent years, scientists have made astonishing discoveries that hint at a different Mars, a world that resembled Earth in its ancient past.
Curiosity is one of a whole series of landers and rovers that have been to Mars. We're looking for signs of organic chemistry, the building blocks of life.
NASA's Curiosity Rover is currently at the forefront of the search for life on Mars, providing invaluable insights into the planet's watery history. What terrifying discovery has the Curiosity Rover made? Join us as we unravel how NASA's Curiosity Rover has unexpectedly discovered potential proof of past life on Mars. From imaginations to discoveries. In the 1800s, human imagination soared as scientists and creative minds alike pondered the possibility of life on Mars. While scientists investigated the potential for Martian life, visionaries like Herbert George Wells pushed the boundaries of imagination further, envisioning a Martian invasion of Earth in his 1898 novel, War of the Worlds. Despite scientific advancements over the years, questions persisted. Could Mars sustain human colonies? Has Mars ever hosted life? The presence of liquid water was crucial in both inquiries, sparking ongoing speculation even after 14 successful Mars missions. By 2005, when NASA's Mars Reconnaissance Orbiter entered Martian orbit, a remarkable discovery stirred excitement. A comparison of high-resolution 3D images revealed dazzling golden streaks in Martian gullies, suggesting the possibility of liquid water and, consequently, life on Mars. Water, essential for all known forms of life on Earth, logically suggests the potential for alien life requiring water as well. Though Mars boasts abundant water, most of it exists as vapor or ice caps, leading many to believe the planet lacks liquid water. However, the unexpected appearance of depositional streaks challenged this notion, igniting speculation among scientists. Further examination revealed that these streaks were not caused by swift water movements, but rather by dry, granular materials, indicating potential landslides triggered by various factors such as rainy weather or a mix of dirt, sand, and water. While the presence of liquid Martian water remained uncertain, the discovery of these streaks underscores the complexity of Mars's geological processes and fuels ongoing exploration and speculation about the potential for life beyond Earth. The hunt for water and secrets of Mars's past. The orbiter was launched into orbit with a clear mission: to search for signs of water on Mars. While its main focus is on detecting H2O, scientists hope it will also provide insights into the planet's geology and environment. Unlike searching for random puddles, the orbiter's cameras and spectrometers are actively seeking mineral deposits left behind by water. To locate potential liquid reserves underground, radar technology is used alongside sounder equipment. Additionally, the orbiter monitors clouds and dust storms with other specialized cameras. The data collected by the Mars Reconnaissance Orbiter is transmitted back to Earth via radio waves through the Deep Space Network and antennas, such as those in Canberra, Australia. Through observations made by spacecraft orbiting Mars, two types of hydrated minerals have been identified: phyllosilicates and hydrated sulfates. Phyllosilicates formed around 3.5 billion years ago when water interacted with rock on Mars, while hydrated sulfates originated approximately 3 billion years ago due to evaporation processes. These findings shed light on Mars' watery past and contribute to our understanding of the planet's geological history. In 2008, the Mars Reconnaissance Orbiter made a significant discovery: hydrated silica or opal on Mars. This finding expanded the list of water-related minerals found on the red planet. The presence of these minerals suggests that water interacted with regions impacted by meteorites or volcanic activity, leading to their formation. Based on these discoveries, scientists estimated that Martian liquid water could be as young as 2 billion years old, which is 1 billion years younger than previously thought. Additionally, the orbiter detected clay mineral deposits, indicating that water played a crucial role in shaping Mars's terrain in its early history. These features, known as plumbing fishes, were likely formed by flowing groundwater in Mars's distant past. In the same year, alongside the Mars Reconnaissance Orbiter, the Phoenix Mars lander also explored Mars. While the orbiter observed the planet from orbit, the lander descended to the Martian surface, specifically to the previously unexplored far north region. Unveiling Martian mysteries. The Phoenix mission marked another significant milestone in NASA's Scout program, which aimed to develop smaller, more affordable spacecraft. Inspired by the legendary Phoenix bird known for its resilience, this mission utilized a lander originally designed for the 2001 Mars Surveyor project, which unfortunately got scrapped. Equipped with an array of sophisticated instruments, upgraded from those on board the ill-fated Mars Polar Lander, Phoenix embarked on its journey. On May 25, 2008, Phoenix made a grand entrance into the Martian atmosphere, zooming in at a blazing speed of around 13,000 miles per hour. After a heart-pounding journey, it gracefully landed on the surface in the serene green valley of Vastitas Borealis. As Phoenix descended, the Mars Reconnaissance Orbiter's high-res camera captured an incredible sight, the spacecraft hanging from its parachute. This breathtaking moment marked the first instance of one spacecraft photographing another during a planetary landing, adding another remarkable feat to the mission's legacy. The Mars Phoenix lander was crafted with a noble mission: to delve into the mysterious realm of the Martian Arctic, unlocking the secrets of its past water history and hunting for intricate organic compounds. Exploring the polar regions of Mars is crucial in our quest for water, as these areas harbor deposits of icy water. Phoenix boldly touched down farther north than any other mission before it, landing at a latitude similar to the northern reaches of Alaska. This strategic move positioned the lander perfectly to unravel the mysteries hidden within the Martian ice. Phoenix was equipped with a set of advanced tools to scrutinize soil samples it collected with its robotic arm. Among these tools were tiny ovens and a portable laboratory. These instruments heated selected samples to release gases, allowing scientists to study their chemical makeup and other properties. Perched atop a 2-meter mast, Phoenix sported a stereo camera resembling human eyes, granting it a high-resolution view of the landing site's geology. This camera not only offered detailed maps for choosing digging locations, but also possessed the ability to identify different minerals in the vicinity. Armed with temperature and pressure sensors, Phoenix gathered data on clouds, fog, and dust plumes, shedding light on the atmospheric processes at play on the red planet, Phoenix's quest for water ice and potential life. Apart from confirming the presence of water ice below the Martian surface, Phoenix made a groundbreaking discovery by detecting traces of perchlorate, a chemical that could serve as a potential energy source for microbes and a valuable resource for future human explorers. Throughout its 3-month mission, Phoenix delved into an icy layer close to the surface, examining soil and ice samples for signs of past habitability. Upon landing, it patiently waited for 15 minutes to let the dust settle before unfurling its solar panels. The initial images revealed a flat landscape dotted with pebbles and troughs, contrary to expectations of rocky terrain in the northern region. Within just 4 days, Phoenix captured a complete panoramic view of the frigid Martian surface, deployed its impressive 8-foot robotic arm, and commenced regular weather updates. On May 31st, the robotic arm began scooping dirt and analyzing Martian soil for ice content. By June 19, scientists concluded that the bright material found in the Dodo-Goldilocks Trench was likely water ice, as it had vaporized just 4 days after being scooped up, marking a significant milestone in the mission's discoveries. On July 31st, NASA made a thrilling announcement. After analyzing a sample collected by the lander using the Thermal and Evolved Gas Analyzer instrument, they concluded that there could be liquid water on Mars. This discovery complemented the data gathered by the 2001 Mars Odyssey orbiter, adding to our understanding of the red planet's watery past. As August drew to a close, Phoenix had completed its initial 90-day mission, which was extended until September 30th due to its remarkable success. On September 12th, the lander scoop delivered a fresh soil sample to its wet chemistry laboratory. Here, an aqueous solution from Earth was mixed with the soil to identify soluble nutrients and other chemicals. Initial findings suggested that the soil was alkaline and comprised of salts and various chemicals like perchlorate, sodium, magnesium, chloride, and potassium, offering valuable insights into the composition of Martian soil. Unfortunately, Phoenix's communication was cut short on November 28th, around 6 months post-landing, due to the cessation of its solar panels' operation during the harsh Martian winter. But the lander continued to send data back to Earth, illuminating Mars' watery secrets. The next mission to Mars, slated for a 2013 launch, was Marvin, a spacecraft aiming to unravel the mysteries of the Martian atmosphere, history, and potential for life. While the Mars Reconnaissance Orbiter and Phoenix Mars Lander made significant contributions, Marvin focused on atmospheric processes, shedding new light on water's presence on Mars. Understanding how Mars lost its thick atmosphere and liquid water over billions of years was Marvin's primary goal. Scientists hypothesized that the weak atmosphere may have allowed water to escape into space, transforming Mars into the desert we see today. During its mission, Marvin studied interactions between solar winds and Mars's upper atmosphere, revealing mechanisms behind atmospheric erosion. Surprisingly, Marvin's data also hinted at the possibility of water on Mars. Analysis showed that hydrogen and oxygen, essential for water, might have escaped the atmosphere through certain processes. While Marvin didn't directly find water ice, its findings sparked excitement about the potential presence of hidden water beneath Mars's surface, possibly as ground ice or ancient ice deposits. Thus, Marvin's discoveries offered a thrilling glimpse into Mars's watery past and its potential for harboring water even today. The discovery of ice sheets in the polar regions, along with seasonal changes like the formation of black streaks, indicates the dynamic presence of water in various forms on Mars. These new findings provide valuable insights into Mars's hydrological history, enhancing our understanding of how much water the planet holds. In early 2019, Marvin transitioned to a lower orbit and took on the crucial role of a data relay satellite for NASA's Mars 2020 rover. This demonstrates Marvin's adaptability and ingenuity as it continues to exceed expectations with its remarkable fuel efficiency and endurance. Despite its original 2-year mission plan expiring, Marvin's mission has been extended well into the future, symbolizing scientific perseverance. Marvin will remain a key player in unraveling the mysteries of Mars until at least 2030, or possibly beyond. Scientists diligently study Mars's past and its potential habitability to shed light on the possibility of life on the planet. However, the question of whether Mars ever hosted life remains unanswered. Curiosity's historic mission. High above the reddish surface of Mars, an alien spaceship is getting ready to land. It's been traveling for nearly 9 months, covering over 500 million kilometers of space between planets. Now, as it descends towards Mars, the robot inside the spacecraft sheds its protective covering. Just 20 meters above the ground, it hovers momentarily before carefully lowering itself using a specially designed hoist. For 16 suspenseful seconds, the robot's fate hangs by a thread made of nylon. Then, with precision, it touches down safely on the Martian soil, marking the beginning of its mission. This mission, aptly named Curiosity, is a significant step in Mars exploration. NASA chose the name well, as it reflects the curiosity of scientists about the mysteries of the red planet. Building on the successes of previous rovers like Spirit and Opportunity, Curiosity represents a leap forward in technology and scientific capability. Unlike its predecessors, Curiosity is much larger, about the size of a small car, allowing it to carry a vast array of scientific instruments. These instruments are the most advanced ever to land on another planet and are aimed at answering one of the most challenging questions in space exploration. Could Mars have supported life in the past? To tackle this question, Curiosity is equipped with a suite of tools, including a powerful laser for analyzing rocks from a distance, a robot arm with cameras and spectrometers for close-up examination, and a drill for collecting rock samples. Inside the rover, these samples can be analyzed by various experiments, turning Curiosity into a mobile laboratory. This shift in approach represents a significant advancement in Mars exploration, Instead of just roaming the Martian landscape, Curiosity is a fully equipped laboratory on wheels, capable of conducting detailed scientific investigations to uncover the secrets of Mars's past and its potential to support life. Curiosity surveys Mount Sharp in the Gale crater. Like the place it was subsequently sent to explore, Curiosity had proven itself to be a truly unique planetary explorer. After years of planning, scientists carefully pored over satellite images in search of the perfect landing spot for Curiosity. Their goal? To find a location on Mars that might hold clues to its potentially habitable past. Their quest led them to Gale Crater, a remarkable site stretching 150 kilometers across, with a towering mountain soaring 5.5 kilometers from its center. This crater, like many on Mars, formed billions of years ago when a massive asteroid collided with the planet's surface, carving out a colossal hole in the rocky terrain. But what's truly fascinating about Gale Crater is its mountain, named Mount Sharp by NASA scientists after the renowned planetary geologist Robert Sharp. Unlike typical craters, which are easy to explain, the presence of a mountain within Gale Crater puzzled researchers. How did such a towering structure come to be inside a crater? The prevailing theory suggests that over time, layers of dusty sediment gradually filled the crater, eventually spilling over its rim. Then, as winds eroded the surrounding material, a substantial mound remained in the crater's center, forming Mount Sharp. Curiosity's journey to Gale Crater is driven by the desire to unravel the geological mysteries held within Mount Sharp's rocky layers. Scientists believe that by climbing its slopes, the rover can uncover millions of years' worth of history, each layer representing a chapter in Mars's ancient past. Satellite observations reveal that the lower layers of Mount Sharp are the oldest, possibly composed of clay deposited by water long ago. As Curiosity ascends, it holds the promise of discovering even more about Mars's watery history and the conditions that could have supported life billions of years ago. As scientists delve into the ancient history of Mars, they aim to understand how the planet's watery conditions transformed over time. Examining the upper reaches of Martian mountains reveals layers of material likely deposited by wind, marking the planet's transition from a wetter environment to its current dry and dusty state. Among these geological formations, Mount Sharp stands as a towering proof of Mars' past. When NASA's Curiosity rover safely touched down on the Martian surface, scientists were thrilled. Mount Sharp loomed on the horizon, beckoning exploration. However, with the mountain 8 kilometers away, the journey would take over a year. Before embarking on this trek, scientists decided to survey Curiosity's immediate surroundings, Curiosity's quest for biological clues. Close to the landing site, scientists observed patches where the rover's descent stage had cleared away loose debris, revealing shallow soil covering conglomerate rock formations. Though intriguing, Curiosity refrained from venturing closer to avoid potential contamination from rocket exhaust. Satellite images unveiled a fascinating discovery: evidence of a once flowing river that emptied into a crater, forming a fan-shaped deposit. It was always part of the plan to target this riverbed, and now the Curiosity rover found itself on the brink of this fascinating feature. Guided by satellite imagery, scientists identified a point just a few hundred meters away where the river deposit intersected with older terrain. This spot promised insights into the ancient history of the crater floor, despite temporarily diverting from the path toward Mount Sharp. Little did scientists anticipate that this detour would lead to a significant discovery, although it would take longer than expected. As Curiosity roamed the Martian landscape, it encountered more clues hinting at Gale Crater's puzzling past. Conglomerate rocks, resembling broken pieces of sidewalk, dotted the terrain, offering glimpses into the crater's geological story. Zooming in for a closer examination, the rover uncovered pebbles with rounded edges, akin to those found in ancient stream beds on Earth. The emerging geological narrative from Gale Crater sparked excitement, but unraveling its complexities would require patience and thorough data analysis. While scientists diligently pieced together the geological puzzle, they pondered a fundamental question: could Mars have harbored life in its distant past? With Curiosity's advanced capabilities, there was also a thrilling possibility. Could there be life on Mars at this very moment? Curiosity's mission held the potential to provide answers, perhaps even plucking them out of thin air. For a decade, scientists were intrigued by reports of trace amounts of methane in the Martian atmosphere. These reports primarily relied on observations from Earth, but indirect confirmation came from Mars Express, a spacecraft operated by the European Space Agency. Earth-based observations indicated that methane appeared to be concentrated around specific features on the Martian surface, such as massive crevices known as nearly fossae, where signs of carbon-bearing minerals were also discovered. If accurate, this discovery would be groundbreaking. On Earth, methane is a byproduct of living organisms, making it a potential indicator of biological activity. However, methane can also form through chemical processes, requiring specific minerals, water, and heat. Regardless of its origin, the presence of methane suggested that Mars might not be a lifeless planet, but rather a geologically and potentially biologically active one, possibly beneath its surface. Now, the Curiosity rover had the opportunity to contribute to the investigation of Martian methane. Unlike previous rovers, Curiosity possessed the technology to directly analyze the chemical composition of the atmosphere. Over 8 months, the rover diligently conducted measurements. Surprisingly, the results revealed no significant amounts of methane on Mars, challenging previous observations and hypotheses. This unexpected finding urged scientists to continue probing the mysteries of Mars, highlighting the complexity and intrigue of the red planet. The earlier reports of methane on Mars had either mysteriously disappeared due to an unknown process or were based on misinterpreted data, rendering those findings incorrect. Such contradictory evidence was not uncommon in Mars exploration, especially concerning the search for signs of alien life. However, with the methane question temporarily set aside, NASA's Curiosity rover still had a lot of tasks ahead. Curiosity's journey to Yellowknife Bay. As Curiosity ventured further into its mission at Gale Crater, it arrived at Yellowknife Bay, a significant location more than 2 months into its journey. Pausing to capture a panoramic view, the rover produced a stunning 1.3 billion pixel image, showcasing the Martian surface in unparalleled detail. Despite covering only about 400 meters, Curiosity's journey had been punctuated by numerous stops, allowing scientists to gather valuable data about the geological history of the area. To the right of the rover lay Mount Sharp, its ultimate destination, while straight ahead, a dramatic shift in terrain caught scientists' attention. Yellowknife Bay presented a complex landscape, characterized by exposed layers of rock resembling steps and slabs. Eager to explore this fascinating site, named after the capital of Canada's Northwest Territories, renowned for geological expeditions, scientists embarked on a mission to uncover the hidden history of Gale Crater. Despite analyzing rocks and soil, neither could provide insights into the crater's past. The rocks, likely remnants of a meteorite impact, and the soil, transported by the wind, offered limited information. To delve deeper into the crater's history, Curiosity sought out local bedrock for drilling. Approaching an outcrop of sedimentary rock composed of thin layers, Curiosity observed varying angles, indicating sediment deposition by flowing water in an ancient stream bed. Continuing its exploration, the rover discovered layers of sandstone and mudstone beneath the surface. The presence of mineral veins suggested deposition by water flowing through cracks, hinting at a distant era when Mars might have harbored lakes and flowing water. This geological puzzle painted a vivid picture of Mars's watery past, sparking excitement among scientists as Curiosity continued its mission of unraveling the red planet's mysteries. Now it's time for today's subscriber pick. As the Curiosity rover navigated the rugged Martian terrain, its sensors hummed with anticipation. After years of tireless exploration, it stumbled upon a crater that seemed to whisper secrets of the red planet's past. Deep within the Martian soil lay a fossilized relic, a tiny shell. The rover's lenses zoomed in, capturing every delicate detail etched into the ancient artifact. It was a moment of revelation, a glimpse into a bygone era when life might have thrived on Mars. Scientists back on Earth erupted in excitement as the images beamed back from Mars revealed the remarkable discovery. Could this shell be the remnants of a long-extinct Martian organism? Was Mars once home to bustling ecosystems, teeming with life forms yet unknown to humanity? Speculation ran wild, sparking debates and fueling imaginations across the globe. The discovery sparked a renewed fervor for Martian exploration, igniting dreams of manned missions and colonization efforts. As the world eagerly awaited further revelations from the Red Planet, one thing became clear. The Curiosity Rover has discovered potential proof of past life on Mars, and the discovery is just the beginning of a thrilling new chapter in humanity's quest for answers about our place in the universe. Curiosity's clues to ancient life. Recent findings from NASA's Curiosity Rover hint strongly at the potential for life on Mars. A unique hexagonal pattern resembling a patchwork of ancient mud patches remarkably well preserved has been discovered. This pattern suggests that early Mars experienced cycles of wetness and dryness, which could have played a crucial role in providing the necessary conditions for microbial life to thrive. This revelation marks a significant breakthrough in our understanding of the Red Planet. The rover stumbled upon these fascinating mud patches while drilling a sample from a rock target known as Poner. Situated in a transitional zone between layers rich in clay and sulfates, these hexagonal formations continued to grow even after additional sediment was deposited. This indicates that the wet-dry cycles endured for extended periods, potentially billions of years. The robust sulfate crust surrounding these mud patches has preserved them over the eons, as confirmed by Curiosity's advanced CM-CAM precision laser sensor. Furthermore, the presence of this crust suggests a close association with sulfate-rich regions on Mars. This discovery provides concrete evidence that Mars's climate in the past followed predictable wet-dry cycles, similar to those observed on Earth. More importantly, these wet-dry cycles may have played a crucial role in facilitating the molecular development necessary for the emergence of life. The conditions required for life to persist are complex, with water being a fundamental component. Achieving equilibrium in the chemical composition, particularly in regulating molecules that contribute to the formation of polymers like nucleic acids, is crucial for the emergence of life-sustaining processes. The mud patches at Poner represent more than just a geological curiosity. They offer a glimpse into what could be remnants of the primordial environment that sparked life on Mars. Ancient landscapes and life's origins. The geological stability of Mars, with its limited tectonic activity compared to Earth, has preserved ancient landscapes for scientists to explore. This unique characteristic allows researchers to delve into much older parts of Mars's history, providing valuable insights into the planet's potential for hosting life. The proximity of Mars, coupled with its well-preserved geological features, presents an invaluable opportunity for humanity to unravel the mysteries of our neighboring planet, and perhaps uncover the secrets of life's origins. Mars remains a treasure trove of mysteries that could hold the key to life as we perceive it. The recent discovery serves as a poignant reminder of this fact, underscoring the importance of maintaining a consistent pace of exploration on our neighboring planet. Initiated by NASA's Jet Propulsion Laboratory, the Curiosity Mars rover project stands as a beacon of hope for unraveling the secrets of Mars. Among the myriad questions Curiosity seeks to answer, an important one is whether Mars could have been hospitable to bacteria at any point in its history. Through careful analysis of Mars's temperature, geology, and past environmental conditions, Curiosity sheds light on the planet's evolutionary journey and the factors driving its remarkable transformations. The discovery of organic compounds embedded within Martian rocks, coupled with evidence of ancient lake habitats that could have nurtured microbial life, represents significant milestones in our quest for understanding Mars's habitability. Moreover, Curiosity's relentless exploration provides invaluable insights into the Martian climate and atmosphere, offering continuous observations of weather patterns and environmental conditions on the Red Planet. Despite surpassing its initial 2-year mission plan, the Curiosity rover continues to operate seamlessly, transmitting a wealth of invaluable data back to Earth. Its extended mission underscores the enduring commitment of scientists to uncovering the mysteries of Mars and exploring the amazing prospect of life beyond our home planet. These achievements not only broaden our understanding of Mars, but also pave the way for future exploration endeavors of the Red Planet. The race to Red Planet colonization. SpaceX, in collaboration with NASA, has set its sights on launching humans to Mars by 2026. Mars One is vying to be the pioneer in colonizing the Red Planet. They have unveiled their ambitious plan to establish a settlement on Mars. According to their strategy, every 2 years following the initial launch, a fresh crew will join the growing colony. Mars One aims to engage humanity as the mission's audience, orchestrating a global media spectacle around the first manned flight to and settlement on Mars. The key strategy of the mission lies in minimizing complexity. A crucial aspect of this simplification entails the entire crew immigrating to Mars indefinitely, committing to a lifetime of work and residence on the Martian surface. While sustaining human life on Mars is no small feat, it's considered more feasible and safer than attempting to transport them back to Earth. The logistics of a return journey would necessitate the construction of a fully functional and fueled return rocket on Mars, an immensely complex and costly endeavor. Instead, Mars One plans to sustain the initial and subsequent crews by harnessing resources from the Martian soil and atmosphere, thereby providing essential supplies such as water, food, and oxygen. Fortunately, all the required components for the mission can presently be sourced from existing suppliers. Mars One has forged partnerships with various companies, collectively capable of fulfilling the comprehensive requirements of the mission. Thanks to the Curiosity Rover's explorations and discoveries, we now have stronger evidence suggesting that humans could potentially live on Mars. What are your thoughts on the Curiosity Rover's fascinating discovery? Let us know your thoughts in the comments below.